In this video, we are going to discuss about the low frequency analysis of FET amplifier. So, on the completion of this topic, the students will be able to understand the concept of the frequency response of amplifiers. So, here in this low frequency response of the FET amplifier, you can see the diagram that it has two RC networks that is affecting the gain as the frequency is reduced. So, whenever there is a reduction in the frequency, this gain gets affected and it causes below the mid range. So above that, if this frequency is reduced means, then there will be occurring the affect the gain, which causes that is cutoff frequency in the above ranges. It will be present in the mid ranges only. So RC network, which is formed by the input capacitor, input coupling capacitor C1, which is given here, and also the input impedance of the amplifier, and the RC network, which is formed by the output coupling capacitor and the output impedance. You can see the input coupling capacitor and input impedance, and also output capacitor and output impedance, as well as output terminal. Based on the coupling capacitors, also this input network will be calculating the FC value, and in the output network also will be calculating the critical frequency. So as of now we know that is, if it is gone beyond the limit, that is the values can be extended in the case of this voltage and the frequency is calculated. So whenever there is a change in the frequencies, so if frequency is very much reduced, frequency is reduced to 70%, we will be getting the mid band frequencies. So in that, above that region only 70% of the output will be getting. Above that we will be getting the cutoff region. So in the case of the cutoff region, if it is formed, this below mid range will be along the region, that is we will be getting the lower frequencies, mid band frequencies and the higher frequencies. So in the case of the mid band frequencies, you can see that is there will be a stabilized output. So there will be a steady slope, that is voltage gain will be very stable at some frequencies. Above that there will be a cutoff region. So below that can be a lower, or either it can go to the higher frequencies. So in the case of, if you are calculating the frequency response, means at the lower frequencies there will be a steady increase. So this steady increase will be up to only 70%. After that it cannot go, it cannot reach 100%, because up to 70% there will be increase in the voltage gain. After that there will be a steady constant value, constant, this voltage gain will be constant for some frequencies. Then at the higher frequencies there will be a reduction in the voltage gain, that is it starts decreasing. So we will be getting the curve as increased output with a constant voltage gain, then it starts to decreasing. So the mid band frequency we can write it as A bit mid divided by root 2, which we call it as 0.707 or equal to 1 divided by root 2. So here we will be calculating the 3 port networks. One is input network, output network and bypass network. So in the case of input network, we will be calculating the critical frequency, that is FC value, and input resistance. And in the case of the output network, we will be calculating the that is higher frequencies, that is FC, and then we will be calculating the output resistance, we will be calculating there. Then in the case of the bypass network, means we will be calculating the bypass terminal, that is this bypass network will be simplified based on the Thevenin's theorem, and based on the simplified circuit we will be calculating the bypass network. So in the bypass circuit, whatever resistance which are connected in parallel or connected in series, which will be added in the case of the frequency. So we know the frequency formula is nothing but F is equal to 1 divided by 2 pi into R into C. So the resistance and as well as the capacitors which is present in the network, that is in the case of input or output or bypass network, will be added with the advantage to that, so that we can find out the 3 types of network, which is nothing but input network, output network and bypass network. Thank you.